there. Welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about the surface area of pyramids and cones. Let's get started. Okay, pyramids and cones are solid shapes that exist in three-dimensional space. Now, a pyramid has sides that are triangular faces and a base. Important to remember that the base can be any shape. Now, cones have a base, I'll highlight this, and a point at the top. Cones always have a circular base. Let's take a look at a cone. Okay, you can see this cone kind of looks like an ice cream cone. And they always have a circular base. All right, moving on. Let's take a minute to review some of the terms that we've been using over the last few chapters. All right, let's take a look at surface area. We've been talking about surface area a lot lately. Now, the surface area is the sum of all the areas of the faces in a solid figure. To find surface area, we have to calculate the area of each face and then add them all together. Okay, I also want to take a minute to talk about nets. We've talked about nets before. Now, a net is a two-dimensional diagram of a three-dimensional figure. Now, I have a picture here of a pyramid in a net form, and I'd like to show you it with an actual model. So you can see here we have a pyramid. It's got a square base and triangular sides, faces. Okay, now watch closely what happens when I create a net with this pyramid. You open it up, and it becomes a star. And that would be the net of a pyramid. Pretty cool. Okay, moving on. If you haven't already, please take a minute to write down these important formulas that we're going to be using a lot. Remember the area of a triangle? That formula is area equals 1/2 base times height. And the area of rectangles, we can find that by doing length times width. And the area of squares is S, or side squared. So let's talk about the surface area of pyramids. So here's the example. What we want to do is find the area of the base. Now the base is a square. You can see pretty clearly here. And so what we're going to use is the formula area equals side squared. So we have one side 6 centimeters, the other side 6 centimeters. We can assume that all four sides then are 6 centimeters. And what we're going to do is just square it. So the area is going to be 6 squared, or 6 times 6, 36. All right, next we need to find the area of one triangle, just one for now. So what we're going to do is use the formula for triangles, which is 1/2 base times height. Here our base is 6 centimeters and our height is 4 centimeters. So we multiply 6 times 4 gives us 24. 1/2 times 24 equals 12 square centimeters. Okay, now this is important to pay attention. That is just the area of one triangle, okay? Now what we're going to have to do is multiply that number 12 by 4. Because there's 4 triangles. Then we add that number to the area of the square base. Remember that was 6 times 6, 36. So we just add all these numbers together. So the surface area will be 4 times 12 plus 36, which gives us 48, plus 36, which gives us a surface area of 84 square centimeters. All right, let's talk about cones. Now, cones have different nets. I want you to imagine that you could unroll a cone. And I'm actually going to show you a net of a cone. Okay, here's our cone. You might be able to think of it like an ice cream cone. Okay, now watch what happens if I want to make a net of this cone. I'll take this out. And you can see the shape that you see, almost exactly the same shape that you see in the picture there, you can see with this model. It is kind of an odd looking shape, but this is what a net of a cone would look like. Okay? All right, so let's read a little bit more about cones. So remember that cones always have circular bases, like we discussed earlier, and the lighter part is going to represent its side, like we saw with the model. Okay, now we don't call this a face because it has a round edge. So for surface area, what we're going to do is we're going to calculate the area of the circular base right here and the side, and we're going to add them together. Okay, so the formula for finding the area of a circle, we know this is area equals pi r squared, and we're going to use that to find the area of the circular base. Okay, now let's talk about the side of the cone. It's a little bit more tricky. So if you need to pause your video and write this down, it might help you out. So the side of the cone is actually a piece of a circle, and it's called a sector. Okay, and the size of the sector is determined by the ratio of the cone's radius to its slant height, or r over s. So to find the area of a sector, we're going to take the area of the portion of the circle using this formula. All right, and this is what you might want to write down in your math notebook. Okay, area equals pi r squared times s over r, which is for the sector. Okay, and that's going to simplify to area equals pi rs. So let's try one. So what is, the question asks us, what is the surface area of the figure below? And there's a cone just like the one we just looked at. Okay, now that we have measurements of the sides of the cone, let's calculate the area of each. So the circle we know has a radius of 5 inches, and the sector, that measurement is 11 inches. So let's start with the bottom face, or the circle. We have area equals pi r squared, which gives us pi 5 squared, which gives us 25 pi, which gives us 78.5. Now for this side, we use the formula area equals pi rs, which is pi times 5 times 11, which is pi times 55, which is 55 times pi, gives us 172.7. But wait, we're not done yet. Those are the measurements for each of the pieces. So now we need to add them together to find the surface area of the entire cone. Okay, so we have 78.5 plus 172.7 equals 251.2 square inches. So it's really not that difficult if you can just memorize those formulas. All right, now let's talk about pyramids. Let's talk about how we can find surface areas of pyramids using formulas. All right, so the formula for finding the surface area of a pyramid is 1/2 perimeter times the slant height plus b. All right, and this is an important note. So I want you to remember that the area formula for a triangle is 1/2 base times height. And in the formula B, that's going to stand for base. All right, so the perimeter of the pyramid's bottom face represents all of the bases of the triangular faces at once. So that's because it's their sum. So the height of each triangle is always the same. So we can just call this the slant height of the pyramid. So therefore, 1/2 perimeter times slant height is the same as 1/2 base times height. All right, let's try one of these. Now, there's another important note there. I want you to remember that pyramids can have bases of different shapes. You always want to pay attention to that. So the area formula we use to find B is going to vary. So just kind of keep your eye out for that. All right, so what is the surface area of this pyramid? So this is a square pyramid. You can see at the bottom there. It has 4 sides, and the area of the sides is all 8 inches. So the perimeter of the base is going to be 8 times 4, or 32 inches. And we also know that we need to use the area formula for squares, highlight that, to find B, the base's area. So we have the base equals s squared, And we know that b equals 8. So we have 8 squared. So now we know that b equals 64. Now we have all the information we need, and we can put it into the formula to solve for surface area. All right, so surface area equals 1/2 perimeter, highlighter, 1/2 perimeter times slant height times b. So that gives us 1/2 times 32 times 3 plus 64. Use your order of operations to solve. 1/2 times 32 is 16. 16 times 3 plus 64. 16 times 3 is 48 plus 64. So the surface area of this pyramid is going to be 112 square inches. All right, let's also talk about finding the surface area of cones using formulas. Now, cones have a different formula because, remember, they have a circular base. But the general idea is the same. Now, the formula is surface area equals pi r squared plus pi rs. Now, the first part of the formula, pi rs, that's just basically simply the area formula for what? Do you remember? For circles. Okay, and that's going to represent the base area. Now, the second part represents the area of the cone's side. We simply put the pieces together and solve for the area of both parts at once. So let's try one of these. What is the surface area of this cone? All right, well, we know that the radius of the cone is 3 inches, right there, and that the slant height is 9 inches. 9 and 9. So basically all we have to do is put these values in for R and S, and we can solve for surface area. So the surface area is pi r squared plus pi rs. Just plug in those numbers. We have pi times 3 squared plus pi times 3 times 9, which gives us 9 squared plus 27 pi. 9 pi plus 27 pi, which gives us 36 pi. 36 times pi is 113.04 inches squared. All right, last one. Let's look at a real world problem. Okay, Jessica is decorating conical party hats for her party by wrapping them in colored tissue paper. Each hat, let's highlight our data here, or the information we need. Each hat has a radius of 4 centimeters and a slant height of 8 centimeters. If she wants to wrap 6 party hats, pay attention to that, guys, how much paper will she need? Now, this is a little note I made for you here. The problem involves a cone. Now, there's no picture, so it would really help to do what? To draw a net. Now, label the radius and the slant height of the cone. And you can also use the formula. You simply put the radius and slant height in for the appropriate variables in the formula and solve. So let's see how this works out. Okay, surface area equals pi r squared plus pi rs. We plug in our numbers, which gives us pi 4 squared plus pi 4 times 8 times 4 times 8. Which gives us 16 pi plus 32 pi, which gives us 48 pi. And so the surface area is 150.72 centimeters squared. Now remember, this is the point I wanted to make sure you remembered. This is the surface area for only one hat. Do you remember how many she needed to make? It was 6. So all we have to do now is multiply by 6. So we have 150.72 times 6 equals 904.32 square centimeters. That just about does it for this lesson. Thanks so much for joining us, and we'll see you next time. Bye-bye.